Hello, my name is Paul Thomas Edward Cusick, and I do research in just about every field that universities teach in. I'm an engineer by education, and this talk is on how, when, where, and why our life began in our universe. I was invited to submit a paper or talk to Astrobiology Conference, and here we go. So this paper examines the mathematical conditions that were necessary for life to begin. It shows where life would begin in the universe and what the energies level were necessary. Life began 3.5 billion years ago in the region surrounding Earth. So based on my paper Astrotheology, Cusick's Universe, I hereby propose a solution as to how life began in the universe. The foundation is Genesis, but the methods include energy calculations necessary for chemical reactions to support and sustain simple life forms like the amoeba. What follows are the calculations that led to the universe. So we have the golden mean parabola, which is e squared minus e minus 1 equals 0. And when energy in time, space is equal to the energy times the time times sine theta, when energy and time are equal, I'm sorry, when space and time are equal, energy is equal to 1 over sine theta. 1 over sine theta is cos theta, and cos theta is equal to c, speed of light. It's asymptotic to 3. So there's our formula there for when space and time are equal. So we have time times c squared is equal to e, and we end up with 1 radian here. 57.29 degrees is the number that pops up frequently. It's just 1 radian. And this is the golden mean probably in disguise here, because energy is equal to the speed of light. This is e squared minus e minus 1 equals 0. So light, which is essential to life, all life on Earth comes from the light that's provided by the sun, except for geothermal. So my boss had a series of mass pendulums, and when you pluck the first pendulum and let it go, the end pendulum would swing up. And that's the way it is with light. That's how light travels. It's a longitudinal wave that travels through the ether. The physicists didn't think ether existed after Einstein, but it does. And I've shown that in other papers. So we'll just see some calculations on that pendulum. So here, this is the area to watch. You got the force of gravity hauling it down, and you got a force forward, pushed it forward. But because the acceleration of light is 0, then the force is 0. So the length of this vector is the square root of the mg squared minus the f squared is the length of this vector, and so it's equal to the superforce. So 1 over energy is equal to 1 over the force, because force is sine theta. 1 over sine theta is equal to 3.75. 3.75 divided by the speed of light 3 is equal to 1.25, which is your minimum energy level in the golden mean parabola, and we'll see more of that later. Might also note that the determinant here is equal to 4, it's equal to the mass. I don't know what a determinant is. I try to find out from reading books on linear algebra, but I can't figure out what a determinant is. It's just a series of steps and it gives a certain number, and it's some kind of convergence, but I don't know actually what a determinant is, other than it has the value of mass for the universe 4. The eigenvalue is equal to 3. Eigenvalue, determinant, eigenvectors, the square root of 3. And interesting, when you plug the square root of 3 into the golden mean parabola here, you end up with the superforce 2.67 or 8/3. So here we have a diagram we see all the time in astrotheology, and it's a two-pole solution. You have no life down here at 0, and you have life up here at 1. So you have the sine curve. Here's your sine curve and your cosine curve. So we have the sine curve is the force of life, and the cosine is the content of the void, and where they meet is the energy level at pi by t equals pi by 4, or 45 degrees. And this is equal to sine equals cos is 1 over root 2. So this E hat, which we'll see a lot of in this sock, is 1 over root 2. 1 over root 2, which is equal to 707. So there's the golden mean problem again in disguise, and there's your minimum energy level, 1.25. That's the minimum. The golden mean problem is sketched out for you here. At t equals a half, the E min, the minimum, is 1.25. And energy is equal to 1 over time. So there's your E hat equals 1 over time. And that is the energy that allows life to be created. And we'll see how later on. So 1 over the sine of 45 degrees is 1 over root 2. Root 2 times pi by 4 times 2 is 1.111. This is 1 over c squared. But if energy is 1 divided by c squared, it's equal to mass. So sine of 45 degrees here plus cosine of 45 degrees is equal to the square root of 2. This is equal to E. And some calculations that I hope we do. So I'll show that life was inevitable, and it occurred in the time frame as can be expected. The sine curve and the cosine curve are the two poles. One is life, the other is no life. Where they meet is where the energy density is just right to cause life to form, which began 666 million years ago. I assume that the simplest form of life, the amoeba, is the first life form to form on Earth. There probably is life on other planets where there is water. Intelligent life even is not a fluke. It's inevitable. It's the human brain, and human beings are ideally proportioned to the universe, and intelligent life is inevitable. So it's part of God's plan for humans to know right from wrong. That is when Adam and Eve knew right from wrong in the Jewish year 3763 BCE, which is their year's 1. And that's the year they believe the universe was created, 3763 BC. It's actually the year that Adam and Eve knew right from wrong. Not the year the universe was created, of course. So from Genesis I'll read just a little bit of Genesis 1 here. In the beginning, when God created the heavens and the earth had no form and was void. No mass of matter, just energy. That's my words in the brackets. And God said, let there be light. So sun is necessary for life, and there was light. God saw that the light was good, and he separated the light from the darkness. God called the light day and the darkness night. There was evening and morning. That was the first day. God said, let there be a firm ceiling between the waters, and let it separate waters from waters. That's the creation of the atmosphere and oxygen, which is necessary for life. So God made the ceiling and separated the water from the waters above it, and so it was. God called the firm ceiling sky. There was evening and there was morning the second day. God said, let the waters below the sky be gathered together in one place, the oceans, and the dry land appeared, Pangaea, and so it was. God called the dry land earth, and the waters gathered he called seas. God saw that it was good. God said, let the earth produce vegetation, seed-bearing plants, fruit trees, fruit-bearing trees, with seed, each according to its kind upon the earth. Life. That's life. And so it was. The earth produced vegetation, plants bearing seeds according to their kinds, and trees producing fruit which has seed according to their kind. God saw that it was good, so he created life. That was the evening, and then there was morning, the third day. God said, let there be light in the ceiling of the sky to separate the day from light, and to serve as signs for the seasons, days, and years. And let these lights in the sky shine above the earth, and so it was. God therefore made two great lights, the great light to govern the day, the sun, and the smaller light to govern the night, the moon. And the stars, and God made the stars as well. God placed them in the ceiling of the heavens. So there's Genesis' account. It contains all the information we need to have life. We have an atmosphere, we have water, we have dry land, we have oceans, and we have everything that we need to create life, energy. So the rate of change of energy, E hat is just that where the sine meets the cosine. It's 1 over root 2 or 707. So dE by dt is equal to 0.7201. For a cone, volume of a cone is pi, the rate of change of volume of a cone is pi r h, is equal to dE by dt, it's equal to V, the volume, which is equal to pi times the superforce, 2.667 times h, which is equal to 86.06. The volume is equal to pi r squared times h. So we solve that, and h comes out to be 0.324. And we end up with the superforce 2.656. So there's just a simple diagram that shows that when the superforce is 2.667, it's in balance with the material universe. So we have an energy cone here. So when the radius is the superforce, we can calculate the delta H, and this is H naught, where the H begins. And we know that the volume of a cone is 2r squared h by 3. The rate of change of volume is the derivative of that, which is pi r h. So we'll see a little bit more of that here coming up. So the life energy and the universe energy is equal to 0.1016. So we end up with pi down here. That's the time. I'm sorry, that's the energy that is required for life. 1 over pi is equal to 31.8 hertz. 1 over the energy is equal to the frequency. Frequency equal to 1 over pi. So 1 over dE by 1 by dt, and you bring the dt over, and you end up with dE by dt equals 1. And there's the golden mean parabola. There's the derivative of the golden mean parabola. T equals 1. So we have the volume of the cone is pi r squared h over 3. The rate of change of the volume is pi r h, which we just shown. So if the radius, as we shown in the illustration for the cone, is equal to 2.667 and the superforce, we can calculate the volume, and we actually determine a value for h. So velocity equals distance over time. Velocity is the speed of light divided by space over time. Space over time is equal to 4/3 divided by 1 to the power 2 equals 4/3. So dH by dt is equal to 4/3 is equal to s. So if we plug that into this equation for the cone, we end up with mass. 1 over c squared is mass, because energy is 1 divided by c squared, mc equals mc squared. Potential energy equals mc squared. Need a better pencil. So, and this is 1 divided by this c squared, we end up with mass. So here we have the dampened cosine curve, which at t equals 0, it's equal to 0.202. And the dampened cosine is just the formula for the dampened cosine is E equals minus e to the power minus c cos of 2 pi t, which we'll see more of. So there it is. Y is equal to e to the minus c cos of 2 pi t. T equals 1, and we end up with y equal base e, and the derivative of e is equal to the function e. So we have y equals y prime. So because the function is equal to the rate of change of the function, that's why life was inevitable. Life was inevitable when y equals y prime. So is the universe. So here we have the golden mean parabola again. This is the golden mean parabola, and we note that 0.8415 at the sine. The inverse sine of 0.8415 is 1 radian. That's how you get your golden mean parabola. Well, y is equal to 0.0247. 1 over y is equal to 2y. Well, we end up with y equals 0.707, which is our e hat. And when y is equal to the sine of 45 degrees is equal to the cosine of 45 degrees is when the function equals the derivative, because the derivative of sine is cos, and it occurs when the sine is 45 and cos is 45. So here we have the formula E equals 1 over t, which comes from y equals y prime. And so this should be cosecant actually, but anyway, pi divided by cosecant of 1 over pi times 0.8515 is 2.07, which is 2.718 on 2.71, which is equal to base E approximately. And the work is equal to the energy times the frequency. And energy is equal to 1. So we end up with 31.8 hertz divided by W divided by work. So it converges on Watton. So we have the golden mean parabola again here, where T is equal to 1.618. Skip that one. So the rate of reaction for an amoeba is 670 billion reactions divided by 666 million is 100 reactions per year. So the rate of reaction is 2.71, which we've just seen. And the slope of the derivative function is 0.4233, which I call Q's. It's equal to pi minus e. Pi minus e. 0.4233. So the rate times the energy is equal to 1 over 150, which is your energy expenditure, which is 0.869, which is pretty close to 0.866. So here we have energy is equal to 1 over 866 equals 1 over sine of 60 degrees equals the cosecant of 60 degrees, which is equal to c. It's very important because life depends on the energy that comes from light. So we have an endothermic reaction, we have an amoeba, and we have the amoeba plus the change in energy. So we end up with 137 kilojoules per bond times 87 bonds from this monster. And we have 383.6. So 0.3836 plus 0.866 is equal to the 1.25, which is the minimum energy level for the golden mean parabola. The energy density is the volume of an ellipsoid. Assume the universe is an ellipsoid. It might be a torus, but in this paper I'm taking it as a ellipsoid. The volume of an ellipsoid is 4/3 pi times ABC, the three axes. And we end up with a volume of 19,905. So if we take the energy 1.25 and divide it by 19,905, we end up with 2 pi. So 2 pi, we plug that into our formula, we end up with S is equal to a half. And the ln of 0.504, which 5044, is equal to 1.618. Again, the golden mean parabola, it's a root. So T equals a half. S and T equals there, when S is equal to T, it implies that E equals 1 over sine theta cosecant T times C. And then we have a Clairaut differential equation here, which is the second derivative of energy plus gravity is equal to 0. So gravity is equal to the second derivative of energy, which is 2. That's the second derivative of the golden mean parabola is 2. So gravity is equal to 2. So we had the energy density is 1 over S is equal to 0.75. S is 4/3. So C is equal to 4E rho. C squared is equal to 16E rho. And energy is equal to MC squared. Energy hat is equal to M times this value. Plug that in here. We end up with C equal to 3. And M is equal to pi by 4, which is that critical temp T value. So if we take the pi by 4, which is the mass, divided by the volume, divided by the density, is 4 by pi, equal to 0.618, which is the other root of the golden mean parabola. There's the ellipsoid, which is a 1 by 8 by 22, or a 3 by 24 by 66. So the longest dimension is 66. So 66 billion years ago the universe was created. There it is there, 66 billion years ago the universe was created. And here's our dampened cosine curve again. And we end up with 1 over G. So delta H over H dot, that's your change in height over the original height, is equal to the golden mean parabola. So we end up with E hat equals 1.25. There are 56 bonds on the DNA chain of an amoeba, which is 56 factorial, which is 7.10999, which is the superforce squared. And it's equal to 2 plus the mass of an electron. So that's G plus the mass of an electron. G plus the mass of an electron. So life began 2.22 billion light years after the universe. So the universe began 66 billion So 666 less 222 is 444. That's an important number. So we'll skip that one. So the universe is 66 billion years old. It should be. And multiplied by the 2.65% is 5.836. And we have it here. 22 billion light years times 2.65% equals 1.75. 1.75 times 2 is 3.5 billion years ago life began. And when we take the 44.4 as the time since life began, we plug it into the gold mean problem, we end up with 1/7, which is the economic multiplier. The economic multiplier is the number that's required, 1/7, to get an inevitable reaction continuing once it starts. Poisson's distribution. So we have probability density function here. We know that this is the probability density function, which breaks down to y equals e to the minus t. And this probability density function, I know for another paper, is 2t minus 1, which is the derivative of the gold mean parabola. And we end up with 2t equals minus e to the t, and a little bit more. Take the derivative, and it comes down to the e equals 1/7, which is that the economic multiplier. So that's it, it's proven. So the conclusion that Converge's life as expected began 3.5 billion years ago. The prerequisite energy levels are just right at when energy is equal to the speed of light. Almost all life on Earth depends on energy from light from the sun. And there's a couple references. My paper you might look at is Astrotheology, the missing link, and that'll lead you to 100 papers on astrotheology. So that's my talk. I hope you've enjoyed it, and still some things need to be worked out, but we're getting there. Anyway, thanks for listening.